Good morning, everybody. This is the first in a series of Wednesday webinars for the FIWARE Foundation. And this course is about the introduction to core context management. My name is Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation. And I'm here to introduce FIWARE on a technical basis. So, this is what we're going to learn today. The following items, we're going to find out what is context data as far as FIWARE is concerned, what is a context broker and why you will actually need to use it, what is NGSI v2, this is the interface which FIWARE uses, and then we will also introduce information about how to create your data models for your context data, and how to read and update the context data using a REST API. Furthermore, we need to understand how to assign relationships between entities. This is how to link data, and how to register additional sources as context data. The point here is that rather than just being a simple IoT platform, we're able to augment our entities with additional data. And finally, we want to be able to find out how to subscribe to changes in the context so that we're able to understand what's going on, something has happened, and therefore we need to process things further. For those of you who wish to follow this series directly, there is a GitHub repository which holds all of the tutorial materials created by the FIWARE Foundation. You can find it under GitHub FIWARE, tutorials step by step, in which case all you would need to do is to git clone the repository and then follow the instructions in the README. It is assumed for this course that you are already familiar with containerization technologies such as Docker and Docker Compose. If not, you can download the information from the links provided. Obviously, you will need Git to get hold of the sources if you're following it. The thing which we're trying to do here is a REST API, and therefore we are using the Postman tool to send and receive information from the context broker. You can get hold of Postman from the relevant location. And finally, the materials are based on a Linux-based system. So if you're running on Windows, you might need to emulate a Linux system by running Cygwin for Windows. All of the links are available on screen. The FIWARE catalog consists of 5 main areas and approximately 30 open source utilities which you are able to use around the central concept of core context management. This is the context broker. Within this particular episode, we are just going to deal with the context broker itself, but you should be aware that each element does one job and one job well. So therefore, you will eventually be in a position where you can get your context data from IoT devices or robots or whatever, pass it into the context management layer, which will then hold a vendor-neutral version of your current state of your system, and then pass it up on to get further processing using things like business intelligence or big data analysis or whatever. On top of this, there are various deployment tools, and there are also various other components which are multi-layer. For example, when we're dealing with security or, for example, selling your context data. So today we're just dealing with the dark blue area in the middle. We're just dealing with a simple context broker. And this is the diagram which does the hello world for the context broker. So this is the first way which anyone will get into the system. It is not very impressive to do a hello world, but it's a good way to start. So, In order to start, we're going to run using Docker Compose, and you can see that we will require two elements. The FIWARE component we're talking about is called the Orion Context Broker, and it currently relies on MongoDB in order to hold the state of the system. We are opening one port of Note, which is 1026, which is the default port to deal with, and this will then allow us to send information to and from the context broker itself. There's a little script which will start up the context broker, and it needs to make sure that both elements are running. Having done that, we can then make a simple request to find out, is it running? This is the same as the health check, which you can see over here. Just for convenience, I have called Orion localhost 1026 for all our tests. And when we send a request, it returns a little bit of information saying, yes, I have been alive for 20 seconds, and I have a version of Orion. It is usually a good idea to download a specific version of the Orion Context Broker. The latest version is 2.2. Obviously, we'll have more bug fixes and what have you being done. You can also see information about the documentation for this component in the link below. So let's create our first data entity. In order to create a data entity, you need to make a post request with the body holding the information required. You can see that the body consists of a JSON request, and it consists of several parts. Now, every single entity must have a unique ID and type. The ID is, in this particular case, is a URN based on NGSI LD format, which actually repeats the type in the title itself. But this is effectively saying, what is this? It's a type. And who is it? It's this URN NGSI LD store 001. This uniquely identifies the entity within this system. Furthermore, you need to have a series of additional attributes. This is the state of the system. It covers the where are you, in this particular case, a location, but it also gives additional information, in this case, an address or a name. Now, if you're a simple string-based attribute, then you can be just type text, in which case you get the information straight back, or you may be a more complex object, in which case you have a specific type. This would be defined by a schema. This is where the data models come in. And then within that schema, this is using the schema.org postal address schema, which would say, if I have an address, it will have the following attributes. It will have things like street address, address region, address locality, and postcode. So for this particular simple introduction, what we're going to do is create the world's simplest store finder, because we will just have two entities which aren't changing very much. Obviously, potentially the name of the store could change, or the name of the road could be altered by the local authority. And we can also do geoqueries. So when we create this, we would do the following. Effectively, we're doing a curl request, but you could just as easily use any particular language you prefer. You can get this from all sorts of different stuff. So we're just doing a curl request with this in the body as a contact type is JSON, and you can see we are sending a post to Orion localhost. When we send the information, it does not return a response in the body. It returns the response using the HTTP code. So it has created it. If I attempted to create that a second time, it will give me unprocessable entity because we already have something of this ID. The main idea behind FIWARE is that we have a well-defined API. This is this NGSI v2 API, which means that we are returning codes which a developer would expect when sending information. There should be nothing unusual here, and because this is based on an open API specification, Swagger specification, it means that you can actually generate libraries, as we'll see later. So let's create a second store. As you would expect, the body again looks very similar, except the ID has changed and the address has changed and the location has changed. So this is again a well-formed request, and we send this information through, and again, once again, it is created. Having created one or more entities, we are able to retrieve the information. Now, if we retrieve the information without any filters, as you'd expect with a GET request, you get back literally all the information we've sent to the system. So this is the current context of our system, which has got all that information, and it's also got the types of whatever it is and any additional metadata you want to put in. For example, you might have a temperature gauge and you want to put the accuracy level within the metadata, or you might have a reading and it might hold the last value updated in the metadata or whatever. So you can see there's the information here. So far, we are not going terribly deeply into what the context broker can do, but this is the basic step. So the next point is that obviously, because this is a well-defined REST API, if I expand my URL to include the actual URN of the item, in other words, this URN NGSI LD store 001 in my case, I will just retrieve the one object. This is obviously what you'd expect for a GET request. Furthermore, there are additional parameters you can add in to amend the amount of information you retrieve. For example, you may only wish to retrieve certain entities, or you may only wish to retrieve, in this case, key values. If I send this information, as you can see, we've no longer got the type information for each attribute. We still have the type of the object. The object is still type store, but you can no longer retrieve the information about the fact that the address attribute is of type postal address. This obviously reduces the amount of information being passed in. Now, depending on whether you are querying for additional data or not, you may or may not want to have the additional information in your response. So this obviously reduces the length of the response. As I said, this is a very simple store finder. So we can also just get the entities of type store, get the key values, rather than getting an individual entity. You can get entities of a type. So far, we've only got stores in our system, so we get back the store or stores in question. You can see both of our stores are within the response. You can also use the Q parameter to obtain information on a more specific level, so you can start doing queries of a element. Again, if we want to have multiple multiple entities in the system, you might want more than one store, and then have a product or whatever in the system, and then we can use this to say retrieve back all the stores in Kreuzberg, and within this thing, it will just give one response rather than two. You can see it just gives me the second of my two stores rather than both of them. And furthermore, the other main part of the basic entities filtering is we can do a certain amount of geofencing. So you can add in the georel attribute and pass in a geometry saying, can you give me all items which are a certain distance within a location? So this is a location of the Brandenburg Gate, and it says what can I find within 1.5 kilometers? Once again, it's giving the key value pairs, so you're just retrieving the information. And you can see that we can just return the closer of the two stores, which is the one in Kreuzberg. Well, that is very much a hello world of the of the system, but we need to start expanding this information so we can actually start talking between different entities. I've been mentioning this entity. At the moment we have this store entity, but entities and the relationships between them is the key to how you need to use FIWARE and the context broker. So what is a data entity? A data entity is either a real life thing in the world which has got some sort of state. It's got a type, it's got a usually a location, it's got various other attributes which will vary dependent on your use case, and therefore it will have things like how happy I am, or how hot I am, or where, you know, what is the state of my robot, or whatever, and it will correspond to something in the real world. So in this case, a store is a real world bricks and mortar building. A shelf is a real world device which has got objects in. Now you can also have conceptual objects. My product here is something that we sell. It's not an individual object. It's not an individual bottle of beer, but it's saying we sell beer in as a concept at a certain price, and it's some sort of inventory item. Some sort of inventory item is another conceptual entity which is used to link the information between. As you can see, within our product, we just have the ID, its type, and what have you. And again, within the store, we would just have the ID, the type, and what have you. The other entities have these ref attributes. These are relationship attributes, and these can these can link information from one entity to another. Okay, so let's get back to starting some more of the system, and let's get into the entities. Let's start our containers again. What we can do here is that there are other additional endpoints which can do batch operations. So we're going to do a batch create this time rather than an individual create. This batch create, batch delete, batch update, what have you, is just including multiple entities at one time, and we're going to start selling some products. So in a case of a batch update, you have the entity within an array. It's not that surprising. So we can create some products. Once again, it says no content because it successfully serviced the request. It is returning the HTTP responses you'd expect. And we can create our shelves as well. Once again, a shelf would have a location which would be of the appropriate formatted type point using GeoJSON, and it has a capacity and a name and what have you. We can retrieve the information as we did previously by saying, let's get shelf unit 1. And at the moment, we've got no information connecting the shelf to the product. So we need to add in, effectively, the equivalent of a foreign key for a database is some sort of relationship information for linked data. And if you look at this, we want to add in a specific type of relationship. Now, by convention, relationships in NGSI v2 cover are prefixed by ref, so we can add in a relationship of type store, of value store 1, so we can put shelf 1 in store 1, shelf 2 in store 2, and so on and so forth. once again, there's no content. Having done that, with that additional information, we can retrieve the information. We've now got this additional attribute, which is a relationship is always a URN. It has to be a unique value, and it will relate to another entity within your system. So we are now placing the relating the shelf unit to the store. Similarly, we can obtain what the store is, because we can take the actual item in question, the shelf, and ask specifically, using this atterers attribute, what is the store reference. So you can get relationship between the two. This means you can get information from one entity and then get information from a second entity. Doing it the other way around is slightly more complicated. This is finding out what shelf units can be found within an individual store, in which case you need to put the query element for the store and then return the shelf. The query element is saying, give me all entities of type shelf which have a reference store with this value. And this is using the values option here and just retrieving the name of the value. So we're just getting the names of the stores. So you can see it is perfectly possible to combine entities from one another. This is not terribly difficult, but we now need to start coming into more advanced concepts. Okay, so as I said, what we want to do is we want to augment our data from other sources. You can get the information about an entity itself. You can update it using standard CRUD commands, and you can also retrieve information from other sources to try and get hold of it. Now, this particular case, you could have a situation where you get a device which is in the real world, and you want to get your weather information from a weather forecasting service. You could want to get social media information from Twitter. These are all perfectly possible. But what we're saying is that our existing entity has got information associated from somewhere else. So we can attempt to get the information from elsewhere. Once again, I'm loading up the system, but I am now adding in this additional container called the tutorial, which is going to have additional information. This is a simple app which I've created just to show how these things connect together. If we go into the application, it will run on localhost 3000, but I want to look at the event monitor. So that is that one here. At the moment, we've got no requests coming through. Good. So if I send a post request to a well-known receiving endpoint, it will give me sufficient information to say, I am this particular entity, I'm store one, and I would like you to return. I've been told that you can give me the information for the following attribute. So you are able to pass to a third party using a well-known interface. Again, this is part of the NGSI V2 interface, saying this is the information I can give you so that you can give me the remaining information. In this particular case, we have this cat facts API, and it should, when I say I'm store one, I'd like you to receive some tweets. It should give me some information in, again, this is the appropriate response using NGSI v1, saying we have a attribute. When you requested the tweets attribute, I know that this is of type list, and it is retrieving information from the following array. This is actually a live service called CatFacts, which gives you information about cats. So if I ask for the information again, you can see the data has changed. So in order to go back to our FIWARE interfaces, what we would need to do is to say things like, I am store one and I would like to get temperature and humidity from this well-known URL. So this is getting information from a third party. Legacy forwarding is true because I'm using the NGSI v1 interface at the moment and its status is active. Similarly, we can also get the information for our tweets from another location, saying this is get the cat facts from this URL. So obviously, you have a receiving endpoint which then gets hold of the additional information. Once again, it's created. It's no. You can actually see which registrations have been created by making a request to the v2 registrations endpoint. As you would expect, is a GET request, and it says this is what has happened so far, and obviously you can delete using the delete. However, what this means is we can now, when we obtain the store information, which we had done beforehand, takes a little bit longer, but you can see we've now added in additional attributes from elsewhere. So we are able to retrieve the information from a third-party source. If we make the request again, think about it and go back to here, you can see each time I'm making a request, it has been getting information from the random API to get hold of the temperature and the humidity, and also getting information from the CatFacts API. The last payload to an endpoint which was listening in was saying, hey, I'm store one and I would like to get hold of information about tweets. So you are able to retrieve information from third-party sources without thinking too much. So, in order to start connecting this to a real live system, we are going to have to start making some sort of requests between our application and the context broker to say, hey, what's the context? I want to programmatically update the context. Can you give me a information on the context, blah, blah, blah. So we would need to start creating a front end for this application. As you would expect, we have a Swagger specification for this, so it's a well-defined interface. You can see all this stuff about entities, which you've covered beforehand, and all the attributes you can put in. And also, you can get the registrations, and we'll deal with subscriptions in a second, and finally the batch operations. So all of this is well-known, well-defined information. What this means is that when we are able to do this, we are able to, I'll just get down to use the Swagger code gen to generate stubs for the code which you would require to be able to connect to and retrieve data from this system. You can obviously generate these things and then you will end up with a library. Of course, I have done this myself beforehand. So if I now look at my if I now look at my pre-generated Node.js application, I have created that client using this Swagger Gen code gen thing and called it NGSI v2, and then put in an appropriate instance of the client, the default client, which is saying this is where my application lies. It's on localhost 1026, a default port for Orion. What this then means is that I am able to create. I'll go straight to the bottom actually. Create information directly from the client by saying, put any headers in and retrieve the API. All this is documented within the when you generate the stubs. But it's saying we can create a little library which will retrieve whichever entity we are interested in and put it back on screen. So it is a very simple thing to do to end up with something like this, which is, again, you've got these cat tweets are being retrieved from my system by, and then because I'm taking my library, generated library, making a request to a well-known endpoint, all this code is generated for you. And as you can see, we are going, in this particular case, we are requesting to retrieve store one. We then know, because store one has already got a couple of registrations set up for it, we will retrieve the temperature and the cat facts from a third party. And then I'm being requested to list all my products which I've put into my store. So our store has got beer and wine and what have you, and it's got a certain number of things in stock. So you're able to relate the fact that you have a store which has got a location, and you've got items which are being sold in that particular store. And for this particular store, we are tweeting information about cats. There is more information on how to do this within the FIWARE tutorials step-by-step guide, which has got approximately 20 individual lessons on how to do this sort of thing. We're just doing the accessing content. Now, the final element we are going to deal with today is how to do set up subscriptions. A subscription is kind of the reverse of a registration. It's more a case of we have a certain state within our context broker, and there we would like to be informed as a third party when that state has been reached. So it's simply a matter of passing on the information as necessary. You don't want to be continually polling for this information. If you're a service, you want to be informed when it's happening. In other words, don't call us, we'll call you. Once again, we'll get back to our little application when we're ready. That monitor. Okay. To create a subscription, you send a post request to the subscriptions endpoint, which should be a surprise to nobody. And within the various parts of the subscription, you have a subject, which is saying, this is what I am listening to, and then a condition, which is saying, what sort of attributes am I changing? They can get more complex than this. But the other important part is the notification. The notification is saying, when something happens, send a request to the following endpoint. This is sending something to the subscription price change endpoint. So if I send it, Again, you see this 201 created. You can do the usual stuff you'd expect. You can delete subscriptions, or you can amend an existing subscription using patch or delete or whatever, quite easily. And obviously, you can list the existing subscriptions. When you list it, you'll get additional information in it, saying number of times it's been sent and when it last happened. Now, if we go back to my monitor, when you set up the subscription, obviously we don't know what has happened in the past. The context broker itself has no memory, and therefore we will automatically send that first subscription saying there's a price has been changed. So it has received any information once we have set that up. We can also, and I'll do this in a more interactive fashion, I can add in an expression to say only do this under certain circumstances. So the expression here is saying notify me of low stock. So when shelf count is lower than 10, this is it, and this is store 1, send me information about store 1. And we can similarly do the same thing for store 2. Now, if I programmatically reduce the amount of items in the inventory to 5, we can see that low stock has been received for store 2. I can obviously do this completely programmatically through my entire system, which is much more realistically, is that if I have store 2, I've only got 5 bottles of red wine left. If I buy a bottle of red wine, you can see that the event monitor has done the buy action in this particular case, and when it said we've got low stock, it has sent the information about the low stock through to the system in question. So obviously you can then, on your own system, you can do additional processing to cover the necessary stuff to modify your smart solution. In summary, the context data, which we consider to be context data in FIWARE, is a representative state of a physical or conceptual object in the real world. Things like devices, like robots, like cows in agriculture or whatever. It depends on who you are and what your use case is as to what you need to use. And each one of these has a state. It's got some sort of ID, it's got some sort of type, obviously, and then on top of that, it has attributes which are changing as the real world changes. And as we'll see in later systems, you can update these things either programmatically or automatically down to devices. The Orion Context Broker maintains the representation of that state, and you can, as we have seen, you can do this using REST calls, or you can use a library to change the things automatically. And you can augment this data by retrieving information from other sources, or indeed you can read this as linked data and so on and so forth. The important point for a context broker is that a context broker has no memory. If you want to have a record of the previous state of a system, then you will be using a component beyond the context broker. Context broker just holds the current state, and all of these actions which you've seen me doing through Postman are the definition of the NGSI v2 standard, which is an open API specification which is available. It has been rubber stamped by various standards bodies as being a useful interface to use, and you can do basically the following things. It's more advanced stuff, but this is just the introduction. You can do simple CRUD actions. You can create entities, delete entities, update them using the standard HTTP verbs. You can also create subscriptions, which can be used to raise events to send to other microservices. And this is what we use for storing data with memory, which we'll see in a later webinar. And you can also set up registrations to retrieve additional information. This is where we differ from a standard IoT platform, in that we are not device-centric or purely device-centric. We can get information from elsewhere. The NGSI interface, you can see the information. You can get more information from the webinar itself. Also supports things like query filtering. You can get attributes and what have you, pagination, which I didn't show, geoqueries. And that, in summary, is a brief introduction to core context management within FIWARE. So all that it remains is for me to thank you for listening, and hope you've had a good day.